Hello there, my name is Thomas. I'm here today to talk about standard deviation of stocks and time scaling of standard deviation. This is a topic that has been requested on investmentexcel.com, and as such it's in the category popular topics on the site. I will show you today how to use on a historical time series Excel's built-in functions of standard deviation and variance, and I will show you how to manually calculate it so you know what's going on, and then at the end I will show you how to scale the risk measure of standard deviation of stock so that we can rely on a monthly based time series of data to interpret also annualized figures. So this video and the Excel workbook are both available on investmentexcel.com, of course, but also on spotify.com. Let's look at a time series of daily returns of Microsoft Inc. And we got it here, 25 observations, 25 trading days with a return. Now let's just start without looking into the formula, which is up here in the right corner, but let's just have Excel calculating the variance, which is done by this formula var.s on the time series. And as you might already know, the standard deviation is linked mathematically to the variance by the square root of the variance. So I take the square root of the variance here, but in fact also the standard deviation has a built-in function, and we will find it here. So it should give the same result, and it did. Before I do the manual calculation, let's just recall how the actual formula looks like. And the formula I have presented here is the sample variance formula. Today I will not go in much detail or touch much upon the difference between the population variance and the sample variance. We will stick to the sample for today, but please refer to other session on population versus sample variance and standard deviation. Alright, not so much talk, let's look at the formula. And on the right hand side here we have a large sigma, Greek large sigma, which means mathematically that we sum over, and in this case we sum over the observations from 1 to n, and in the case with our time series we sum from 1 to 25, and in that summing we do for each I, that is for each observation, each day in this case, we do the following. We take the actual observation minus the average of the sample, denoted by X with a line above. I don't know what's called in English, so I say a line above. And then we have to square it. If we didn't square it, imagine if we had exactly the same plus and minus difference, they would net out and it would leave with a result as if there was no standard deviation, even though we had plus 10 for instance and minus 10. We have to divide that by a factor 1 over, we have to multiply that by a factor 1 over n minus 1. And except for the minus 1, it sounds reasonable that to obtain a period variance, it's per period. So here in this case it's a daily variance. We have to divide by the number 25, the size of the sample. The reason why we just have to adjust with a minus 1 is because normally when we calculate the variance of a sample or standard deviation for that matter, we would like to have an unbiased estimate of a true population variance. So this was all that I wanted to talk about, the difference between the population and the sample. So never mind, don't think too much about this. It's a statistical adjustment. It's not a mathematical adjustment. It is a mathematical adjustment, but it's based on statistical assumptions. All right, this is the way to calculate the variance. So let's just start from here. First observation, we will take the deviation of the first return minus the average, and I will fix it because the average is used in all formulas. So this was the first deviation. Do that all the way down, and now I have to square it and just do like this. And so now we have all the squared deviations. Now we have to sum them. I can do that down here. Just type sum. So I don't like if there is not a line there. So, and now we can take the sum and do the last little mathematical correction. Divided by the sample size minus this little statistical thing, and we see we get the same result. So now we're just where we need to square root the variance, and we get the same result. So this is the way to calculate standard deviation and variance on a historical time series. And as I said, there's a slight difference if you assume that all these numbers are from if they are population numbers. And of course also there's a huge difference to how to calculate variance and standard deviation in a forward-looking framework where you calculate on stochastic outcomes. This is described in a few sessions also on investmentexcel.com under educational topics. Alright, what can we do now? If we wanted to have Microsoft standard deviation on an annualized basis, because this standard deviation is a daily risk measure. So Microsoft has a daily standard deviation of 0.431, and now I would actually like to have it on an annualized basis, because that is normally what we talk about when we talk about risk on a stock, for instance. It's a annualized risk figure. We need to apply what is called the square root model, and the square root model is a simple relationship between a for instance, a monthly observation to annualization to yearly, or from daily to yearly, or the other way around, from yearly observations to monthly annualization. And the formula looks like this. So if you have monthly observations and you like to have a measure for the yearly or the annualized standard deviation, you have to multiply it by square root 12. And here, if you like to have monthly numbers but you have yearly, you need to multiply the yearly standard deviation with a factor 1 over square root 12. And this is used in practice all over. Not so many knows why it is used. It is simply just used, but underlying this principle is actually an assumption of what we call IID, that we have identically and independent distributed random variables. So we assume basically that the time series that we have constitute a sample that is taken from a distribution on each period, on each observation, and that the observation outcomes, they are independent and they have same distribution. So same distribution on all, in this case with Microsoft, all days, same distribution, and the outcomes, the returns, they don't have a dependent structure. So this is how we can infer other time another time scaling or another time measure of the standard deviation, is by assuming the IID. So that's pretty much it, and I will hopefully teach you later.